Hello, welcome to this design session about NUMA balancing and scheduling in Zen. So before we start, maybe I'll just give a quick summary on what we've done in the Zapi project in terms of NUMA balancing and what the problem that we're trying to solve is. And something similar also exists in the Excel tool stack in Zen. So we have this short overview in the Zapi project. The link is in the design session if you want to read all the details. So for now, I'll just maybe discuss this diagram a little bit. So when you have a system with more than one socket, you typically have your memory both close and far away from a CPU, right? So you have some memory that's close by to CPU 0, some memory that's close by to CPU 1. And that's where you can access it with the lowest latency. Of course, CPU 0 can still access the memory that's closer to CPU 1, but in order to do that, it needs to go through another interconnect, and there might be additional latency, there might be bandwidth limits. You would really want to run your VMs as close as possible to where its memory is. And by default, what Zen does, I think it interleaves the memory from all the nodes, and then the vCPUs run wherever they run. But it has this feature where you can set a hard affinity mask, so you can restrict where your VMs are running. So you could say my VMs would be running only on this NUMA node, or they would be running only on that other NUMA node. Now, obviously, this static partitioning is not ideal because you cannot predict which VMs will need more CPUs, right? If you do a static partitioning, one of your NUMA nodes could end up being completely idle while the other one is overloaded. So Zen also has a feature called soft affinity. So you could say that your VM preferably runs on this NUMA node where its memory is. But if it can, because it's busy, Zen will run it somewhere else. And when it's available, it will try to run it where it's originally present. So this is how it would actually look like if you run Excel vCPU list. You see the DOM ID, you see all the vCPUs in the domain. So this is the vCPU number. This is the actual physical CPU where it's currently running. And then you have the hard affinity mask and the soft affinity mask, so essentially a range of CPUs where they could run. So in the Zapi tool stack, I'm not changing the hard affinity mask. I'm just changing the soft affinity mask to match the NUMA node. So in general, this leads to some improved performance for certain VMs, but there are some corner cases when you start overloading your host. So we have a list of limitations here at the end. Some of these limitations are also shared with the upstream tool stack. Some may not be shared with the upstream Excel tool stack. So one problem we have is that when you boot VMs in parallel, you have a race condition in choosing the soft affinity mask, because currently the only metric we have on choosing which NUMA node we want to run it on is based on available free memory. But free memory is before you started any domains, and if you start 10 domains, then obviously the free memory could run out on that NUMA node, and you'd be better off starting it somewhere else. And you don't really want to serialize starting the VMs either. So having some...
Are you using the memory, what's that called? Reservation? What was that thing that Conrad did? The memory, you know what I'm talking about?
I think you talk about something that was ripped out.
Oh, did they get ripped out?
I think so.
Okay, never mind.
Okay. Yeah, that's why I'm not using it then. Yeah, I mean, we're using a memory reservation API, but I don't have any control on which NUMA node it ends up on. So if we would have something like that, I'd gladly use it.
Meta question. Is this talk just about servers, or is it also about things like P versus E cores on clients?
I'm not sure how NUMA nodes look on client devices. Well, actually, I think on desktops, actually, you can get a last level cache split if you set it in the BIOS. So you can split your last level cache and have a sub-NUMA clustering. It might show up as a NUMA node. At least I have that on my own machine. It doesn't work terribly well. But
Okay, because
but I don't think you would have it in a laptop.
okay, the reason
It's
I'm
mostly
asking-
about servers.
Okay, yeah, I'm gonna head over to the Unicraft.
Okay. Yeah, so one problem is this race condition, which could be solvable by introducing some API in Zen to do this kind of reservation. And then the other problem is what happens when you run out of memory on that NUMA node. Obviously, you can either allocate it from another NUMA node so that your VM keeps booting, or you might prefer to get back an error. And some users, some of our customers would prefer it one way, some customers would prefer it another way. So having an option in the tool stack to be able to detect when you run out of memory and what to do next would be good. So even if it's something after the fact, if I could go on and query Zen which NUMA node it has allocated the memory on. Because currently the only way to query that I'm aware is to use debug keys, and then you would dump it in the output, but that's not an API, right? That's a debugging tool. So the information exists in Zen. We'll probably need to introduce some way to query that information. But I mean, these are all small things that are solvable. Some of the more user-visible things are some problems with what happened when you overload your CPUs. And I think I tried to write that down here. So essentially, you can get into a situation where most of your CPUs are not running on their preferred NUMA node. Let's say you have host A and VM A and VM B, and most of the CPUs from VM A are actually running on the NUMA node of the other VM, and most of these CPUs are running on the NUMA node of this VM. And at least on credit one, from what I discussed with George, most of these decisions are local decisions. And if you don't have any idle CPUs, then you cannot move the VCP of this VM to its preferred node according to its soft affinity mask, because it's all busy. So you run it somewhere else, which is the wrong place. And when you look at the other VM and try to run it, again, you have the same problem that the preferred ones are all busy, and then you can only run it. But you don't realize that if you would swap these two CPUs around, you'd solve the problem for both of them, which, as understood, credit 2 might be able to do, although credit 2 might have some maybe other issues. So this one might be something that could be worked around in the Zen scheduler, or there's something we could also do in user space. One workaround I found is that you can temporarily set a hard affinity mask to move everything back together, something like IRQ balance would do, like maybe you do it periodically, and then you remove the mask, right? And you let things run. And if you notice that they're too out of place, again, you set the hard affinity mask, move them back together, but it seems to be more like a workaround. So if it would be possible to at least get some statistics from Zen on how often it runs in the wrong place, right? Of course, I can poll from user space where things are running, but that's just a temporary snapshot. And Zen itself knows how often things are running out of place, so we could have some kind of counters there that measure how often this CPU runs in the wrong place to have some more accurate statistics rather than polling.
How long, not how often, but
How long, yes.
Well, I mean, so keeping in track of like how busy a CPU is and how much a CPU has been running and that kind of stuff, that's one of the things that Credit 2 does. Whereas Credit 1 is just like, at this instant, is that free? No, you're done, right? So I think there are some simple things you could do. You could basically say, okay, if there's nobody on that node who belongs on that node, right? Or basically, instead of saying, are there any cores on that node that are idle, you say, are there any cores on that node for which there's nobody who is that's a local thing, right? Then move over there and give yourself a little boost, and then maybe that guy will be bumped over to. Then basically that guy will be bumped away somewhere else. Maybe it'll be bumped away to his own node. Maybe he'll bump away to a different node. But either way, he's not the worse off because he's still not.
He was in a bad place to begin with. Right?
Yeah. So eventually that might be a thing where eventually everything kind of ends up on, like, things tend to gravitate back towards their own node, rather than having a stable thing where everybody's in the wrong place and nobody's happy, but nobody can fix it.
Yeah.
One thing I think the idea with like the IIQ balance having some kind of user mode daemon trying to fix things would be a good idea, because this would be scheduler agnostic basically, with some limitations maybe, but on the other hand it would work for credit 1 and credit 2 and maybe for others as well. Yeah, so if by playing with affinities or just a new hypercall or whatever, yeah, to move the vCPUs explicitly from user space to rearrange them from a daemon which has the global overview basically would be not the best idea.
You say the instant you make the hypercall, stuff could change behind your back. Right? You hold it in lux, and as soon as you make a decision, you do something, everything changes behind your back, and it could change all back at the next instant, right? So
Yeah.
I don't think doing user space is really going to be useful. So.
Yeah, but on the other hand, it's using more statistical data, so it will always be some kind of statistical approach, right? Because even if you act locally and try to fix it locally, it can change a microsecond later and things will be ruined again. So that's not really a reason to do it in the hypervisor only, in my opinion.
One thing that's missing that user space daemon could also do is migrate pages, right? Because currently all the allocation is static. So even if soft affinity works perfectly, we still have the problem that if you're on an overloaded system, you don't know how your load is going to be compared to when you booted. It can change at runtime so much, and if you don't have an easy way to migrate just the pages without migrating the entire VM, then it's a bit difficult to fix them up. Like, I don't want to do a full VM migration just to fix up which NUMA node it's running it on. If you would have something lighter weight to migrate only some of its pages, or migrate just the pages of a VM without doing a full VM migration.
Yeah, okay, but this is a little bit more complex without pausing the guest, because you have to consider it's kind of a really like migration, only a partial migration, but still a migration, right?
Yeah, you might actually introduce problems because you need to stop the guest a little bit to swap over the pages, and then you're introducing pauses in the guest all the time. So.
Correct.
So you would only do that if things are really bad and you notice that, I don't know, for hours along the balance is wrong.
And the next thing to consider is, which is even worse in my opinion, is what happens if you have a guest spanning more than one NUMA node. So having more vCPUs than one NUMA node, or more memory than one NUMA node. So this is something else which is quite complex, I think. I'm not sure if you're going to cover this.
So what Zapi does is basically something fairly simple. So we try to pick the smallest amount of NUMA nodes that fit your memory, but we don't look at the number of CPUs, right? So we try to pick the smallest number of NUMA nodes that fit, and if it's not one and it's two, we try to choose the ones that are closest to each other at that time. But obviously that's again a static choice.
Do you have any ideas? So any metrics how you then allocate the memory? Is it 50-50 or is it one?
Well,
as much as possible
on the
one?
NUMA matrix, but I don't have any control on how Zen allocates it, right? So I just set the soft affinity to be the union of those two nodes, but then I rely on Zen on interleaving the memory, which is again maybe not ideal because I don't have any control on is it an equal split.
So in order to do that properly, I think Zen is missing some interfaces to properly expose some sensible NUMA topology to the guest. It's also missing some interfaces to properly ensure that some vCPUs are tied to one of those NUMA nodes and other CPUs are tied to the other, so that then...
That's there.
You can set the soft affinity. So soft affinity means please run here if you can. If you can't, run there somewhere else. You can set the soft affinity on a vCPU.
Right.
And then you can allocate memory out, and then you can basically. There is some. I mean, a long time ago, Oracle
Oracle did do some work to do PV NUMA stuff to basically tell the guest, here's your NUMA layout. But basically, I think they got something working, but I'm not sure how well they tested it, and then they kind of left and did something else. And I mean, Andy said last time he tested it, it made all performance 1,000 times worse, or whatever, not 1,000 times, but it made it a lot worse. Which I mean, I can believe because no one's ever tested it and tried to make it work. But like the actual, there have been drafts of PV interfaces to tell the guest, this is your virtual NUMA layout. These vCPUs have this memory local to it. These vCPUs have this NUMA local to it. So all the different pieces to assemble a virtual NUMA stuff, the basic pieces are kind of there or have been, kind of designed. What state the PV NUMA stuff is in, I'm not sure, but
That's a paravirtual device.
What's that?
That's a PV interface. That requires alignment from the point of view of the guest.
Yes. Well, so the other thing you would do basically is then to expose the a NUMA topology via, whatever, ACPI or something like that.
The ACPI tables and everything else. So that is exactly what I mean. If we don't expose a NUMA topology in an architectural way to the guest, then the guest might simply not make use of it. If then the CPU, the vCPUs that we have are not properly tied to the same physical NUMA node, or we are not careful when we are allocating the memory to allocate part of it on one side and part of it on the other side. And as far as I know, we have no credible way for the tool stack to express that.
Yeah, we totally do. Yeah.
Yeah, so the tool stack, and I'm not sure what Zappy can do, but you can certainly make a hypercall that says allocate, this memory from this node, allocate this memory from this node, and then you can say, take these vCPUs and give them a soft affinity for this node, and these vCPUs a soft affinity to that node. And now all you have to do is tell the guest, these vCPUs are local to this memory, these vCPUs are local to this memory, and then the guest can do whatever it's going to do. So move to the pieces. So all of the pieces from Zen's side are there. The only thing that's missing is the no. Okay, enlighten me.
You specifically cannot say what node you want to allocate memory from.
It's sort of inferred, I
I want
think.
this much memory, but that's it.
Yeah, and
Wait, there is a way, but it is not being used, I think. Yeah, you're right.
so
I'm pretty sure there's a hypercall you can say allocate it from this node.
You're right.
So, but what is missing is, for one, if the guest is ballooning in and out, all this nice allocation locality to NUMA node is gone, because the guest can just say, give me some memory back, but not where from.
One more thing with the delete.
Yeah, right. That's one thing. And memory hot plug, of course. No, memory hot plug is fine, probably. But I think for the ballooning interface, we are really missing something.
Right. I kind of consider that ballooning is fairly basic, but it's not,
Yeah,
you
right.
could just say don't balloon, and then your stuff would work, right? So, which is not completely unreasonable.
Is there a way to query where the memory ended up? I suppose if you want to build the
No, I don't think
tables.
so. I don't think so. So what might be possible if the guest will populate it? I think it says the PFN. So the guest is telling the hypervisor where to populate the memory, right? In its guest PFN.
The tool stack.
No, in ballooning in again. It says populate memory and is giving a PFN where to populate it. A guest PFN.
Yeah.
A guest PFN. So the hypervisor could know then from which node to take it.
Right, but right now Zen doesn't have a concept of virtual NUMA nodes.
Correct.
Right. So So basically, the tool stack can tell Zen allocate this PFN from this node and this PFN from this node, but then Zen forgets that.
Right.
So we would have to add an extra bit of stuff so that to somehow tell Zen if the guest tries to fill in this PFN again, then you get it from this node.
Right. So the hypervisor would need to know this PFN range is from that NUMA node, basically.
And that would be PV only.
Why?
In HVM, the guest doesn't say anything about
It says for a guest PFN to populate.
PFN.
Well, this is only for
okay,
ballooning, and if you're
Yeah.
ballooning, you are already aware of Zen.
Yeah. Yeah, but nevertheless, the guest says which frame number should be populated with memory again. And this can be done according to,
Yes.
might be possible to do according to the NUMA topology, depending on memory availability, of course.
Can the best vary which NUMA node is going to be used?
That's none of his business.
Yeah, I'm just checking what Zapi currently does. So it does this reserve memory, and then it add reservation. Maybe it could just be that we don't have the proper thing bound in the OCaml binding. So this one only has reservation ID and an amount, and this, right. So.
We definitely want to expose something so that at the point in which we probably want to expose something on SAPI so that when you are making the memory reservation, you can optionally say, I want this much memory from one node and this much memory from another node. And these are now nodes 0, 1, 2, and 3.
I mean, if we want to support ballooning, then probably a better option would be to have a hypercall to tell Zen, please allocate this PFN range from this node and this PFN range from this node, and then have the tool stack just say populate it, and Zen will do it automatically, rather than having to teach the tool stack to change which hypercall the hypercall uses to populate, right? Because we already have to tell Zen if we're already going to tell Zen, this PFN range for this node, this PFN range for this node, please, then we could just say populate it and have Zen take care of it.
But you have to tell it anyway.
It's a tiny bit simpler, right? Then you have one source of truth, and that is what you've told Zen, right? And so then you don't get a situation where you tell Zen this range for this node, but accidentally somehow allocate it from the wrong node, right?
And this would even work for populate on demand, right?
Yeah.
I mean, I could probably try getting the reservation without ballooning working first, and then see how to add the ballooning one.
Do you have guests with populating on demand?
Well, we do, but we don't really like to have them.
Yeah, so if you have lots of them, you might consider this approach because otherwise you're completely off. You can allocate memory from the tool stack as you like, but when most of the memory allocation is done at guest initialization time by the guest itself, you're lost, basically.
Yeah.
With populate on demand, I think with just ballooning in general, because you can't tell the balloon driver, please free stuff from this node so I can give it to this guest and then to that node. You see what I'm saying? So I think overall I would, as you say, even just ballooning entirely, I would really try to avoid it for NUMA guests, because it just sounds like a nightmare to try and get to work right.
You could even solve the issue of parallel guest boosts by this way, right? If you have an idea about the NUMA nodes and the memory usage of the NUMA nodes of the host, and allocate the virtual NUMA nodes of the guest accordingly and spread the memory as you like, then the allocation would just work correctly.
Yeah, if the tool stack could know, and I mean, it
has the overview over all guests, basically.
Yeah. It would do doing the allocation is a cheap operation. We can do that under the lock without actually doing the actual allocation.
It only needs to allocate ranges on the NUMA
yes.
nodes.
Yeah.
And tell the hypervisor about the NUMA node placements, basically, the virtual NUMA nodes.
Yeah.
And to which physical NUMA nodes they rely, and then the allocation would just work.
Yeah, yeah. And that part can
Automatically.
be parallelized in the hypervisor already. If the tool stack has decided on the ranges, we can parallelize the actual allocation hypercores, because that's the problem currently, that I would have to serialize currently everything in the tool stack, including all the allocation done by Zen. So, yeah, we can split that apart, and yeah,
Correct.
that's useful. I think there are a few other problems here. Let me just see which ones are the most important ones. All right, so I was also trying to get NUMA working in DOM0. That was a few years ago. Maybe the situation would be different now, but if I just tried to enable NUMA in the kconfig, my DOM0 wouldn't boot. I didn't have too much time to debug why. I don't know if anyone else has tried enabling NUMA in DOM0 and have some success with it. No, it's a regular PV.
Yeah, so PV, I'm not sure this is something which will ever work. So I'm not sure I would like to introduce NUMA in PV DOM0.
It cannot work. The APIC IDs themselves are gone. There's no way of knowing where they are, and the vCPUs move.
Yeah, okay, but you could in theory do identity pinning or whatever. So this would be possible to solve, because it's possible for normal DOM use as well, right? Soft affinities exist. But nevertheless, I think it will be quite a nightmare to handle this, because PV DOM0 will get its memory initially, and then it will self-rearrange its memory to fit the host memory map. And this is kind of wrecking all of the NUMA stuff at once, I think.
So you're thinking that PVH might have a better chance of working with this one?
I think so.
Okay, so we'll probably, don't spend too much time on PV DOM0, and yeah, I'll wait for PVH DOM0 for... Yeah, because then if we could do NUMA inside DOM0, then I could also run my backends in the place where the front end is, to try to see if I can speed things up that way.
The memory accordingly.
Yeah, yeah.
But that's something else to consider, how to tell the hypervisor at DOM0 creation to do that.
Yeah, you would have to essentially split DOM0 at least in two. So you would have half of its memory in one NUMA node, half of its memory in another one, so at least you have some chance of allocating the backend pages from the, allocating some pages that need to be shared from the correct place, right?
Wait.
Yeah, if you end up, I think when you boot DOM0, you end up, I think, with everything from the first NUMA node or something like that.
But then you have no way of actually choosing which pages will land in, I don't know, QEMU or whatever your backend is.
Yeah, you would essentially need to expose the map, like the NUMA map into DOM0 as well, so it knows where its memory is, right? So even if you allocate it from all the NUMA nodes, it needs to know which memory range is on which NUMA node, so it knows.
What memory do you, so why would you want to spread DOM0 then? Would you want to run its vCPUs on all NUMA nodes?
Yeah, I mean, ideally, yes, so I can run some of my backend processing on the NUMA node that's closest to the guest.
Yeah, but then how do you control which memory it uses for these vCPUs? So it will not only use the guest memory, but it will have to use its own memory as well. So then it will, it's basically, it's one backend. Yeah, okay, it has some guest-specific memory maybe, but...
yeah, it's really difficult to do because you have both kernel backends and QEMU backends, and
right.
Each of them will need to be NUMA aware so that it places its allocations according to the soft affinity of the guest. So, yeah, I'm not sure exactly even...
So
would
the
be even get
QEMU
benefits.
side might be doable because you can, in theory, limit it to the vCPUs which are running on the correct NUMA node. So QEMU will allocate its memory from there because it's...
Yeah, because that's where it's running.
Yeah, that's where it's running, and if DOM0 is NUMA aware, it should do so, right? But the kernel backends, I don't see how this would work.
Yeah, although I think...
Now you should be able to say what node you want to allocate from.
Yeah, right,
It's,
right.
It's,
Yeah.
it's entirely, as Evian said, NUMA awareness of the driver, which
Yeah,
doesn't exist.
right. Okay.
Surely you must be able to do that for hardware devices if your hardware device is IO NUMA
Yeah,
closest to.
Exactly. There is the other reason of having NUMA memory in order to run the devices close to the memory.
Yeah, right. So you might have to choose whether you want to be close to the device or close to the guest.
Yeah.
If you're lucky, you're close to both, but
Yeah, you could be that they are this apart. Yes.
it's a multi-dimensional problem, basically.
Yeah. And yeah, you could be close to the network card or you could be close to the guest. But I mean, at some point, you could also take that into account when you allocate your guest. If you have multiple network cards, you could allocate some network cards on some backends on network cards that are closer to this guest, some network cards that are closer to that guest, especially if your network cards are in a bridged mode in some way, if you have sufficient network cards, right? So you could do some hardware balancing, but I mean, that's out of scope from what I'm trying to do right now. It's just maybe something to consider in the future.
And of course, you should try, if you have threaded interrupts for a device, you should try to start this interrupt thread on the correct node, right?
Yeah. But at the point that when we have at least PVH and NUMA aware DOM0, then at least the hardware drivers would start running in the correct place. But currently, DOM0 cannot know where its hardware drivers will allocate memory from, right? For the real hardware. So at least we should get an improvement on that side when we get there. I think that's most of the issues that I had there. I think there's maybe one more. Let me just see. Oh yes, there was this idea that okay, you can have any number of NUMA nodes on a system, but they are usually powers of 2. So we could do something like have the biggest level NUMA node split as a hard affinity, everything else as a soft affinity. And then you could expose this topology to the guest. So you could actually give the guest on purpose more NUMA nodes and have it know that it has multiple NUMA nodes so it can split its workload accordingly. But in order to do that, you need to know whether in reality, is it always going to have 2 NUMA nodes, especially if it's being migrated to different hosts or not. So if we have this top level hard split, but in order to do the hard split, I probably want to have the migration first, but otherwise you might end up in places where we have an imbalance we cannot fix.
One other notice, I've seen just this note that you tried enabling NUMA and kconfig, and this resulted in a kernel that failed to boot. So at SUSE, our kernels are for sure built with NUMA enabled in kconfig. And
in DOM0?
DOM0, we always use the same kernel everywhere.
Okay.
So absolutely, it is working for us.
Okay, so it's,
Or being
NUMA.
The kernel config option, NUMA.
okay. Is that what you're?
yeah, that's what I tried to enable. I mean, it could be some incompatibility with something in our patch key, or it could be something that got
or
fixed.
some interaction with some other kconfig option. But on the
Yeah.
other hand, if there would be something like that, I guess that
Yeah, this was on a 419 kernel, I think.
nevertheless. So if
This-
there is something, this should have been caught by the how it's called, this automatic build run config, which is done all the time, basically on upstream kernels.
Wouldn't go unnoticed for long.
Right.
Okay, so it's probably something local to our kernel. It's not that it's in general broken.
Yeah, probably.
Okay, I probably can look into that in more detail, but like I said, maybe just wait for PVH and it's a better way forward. Yeah, I think that's most of what we have here. So there's also this old wiki page on how it works on upstream Zen. I think it's a little bit different from how it works in Zapi. So in Zapi, I also try to do this to get the smallest number of NUMA nodes that it can run on. But obviously that's a combinatorial problem. So if you have, I think I limited it, if you have too many combinations to try, I give up and I only try the smallest and the largest. 'Cause I think at some point it becomes exponential to try to find the closest NUMA nodes. And even if you have like only 16 NUMA nodes, you start getting a lot of combinations to try. So I put a hard limit in Zapi, don't remember the exact number. And if you have more combinations than that, it basically gives up and says, okay, I'm going to try to allocate this VM on the smallest number. And if that fails, basically just interleave it on all the nodes, because I can't do anything better. I mean, we could try to do something different there, but so far I haven't seen in practice CPUs with too many NUMA nodes. I had one system which had 8 NUMA nodes. It was an AMD Interlagos, but since then it's mostly like 2 or 4 at least what we have in the lab. So I suppose we'll have to see what our users and customers say on do they really need some better NUMA support on large NUMA machines, and what can we do in that case to find something. Maybe we can have a different algorithm that finds a better allocation, maybe taking advantage that sometimes these distant matrices are somewhat symmetrical, but they aren't always symmetrical. So
Yeah, and I think there are some quite huge systems with 64 or even more NUMA nodes, right?
yeah, you could have a lot more NUMA nodes. Yeah, and there are some special cases that I didn't handle, like if you have a NUMA node with no attached CPU or things like that. I
Or
don't
no
have-
memory
or
and
no
stuff like
memory,
that. Yeah, those weird cases.
Are there any other questions or suggestions? I think Bernhard had some. Do you want to present your slide as well?
No, it's such a question about the page migration. I only looked at page migration in the Linux kernel many years ago, and I saw there it's used for a number of use cases like memory compaction, getting contiguous areas of memory. For that, you have to free a contiguous block of memory. For memory poisoning, when memory chip is going bad, you have to evict the pages, and so the mechanism is there to do this without stopping the whole machine, at least not for long. And I wanted to ask if it can be possible.
Yeah, I think in theory, yes. So I've run across this page migration issue in the Linux kernel when we hit problems with hypercall buffers suddenly giving page faults. Because that was the other way around, right? Because the kernel was migrating a page even if it was basically pinned in memory. So a page table entry could become invalid for a short period of time, and we hit that in the hypervisor. And some tests were failing. I think this was in the 4.10 or 4.11 Xen time frame but nevertheless, doing that in the hypervisor might be possible, but this would again mean that quite some complex handling would be needed. So I think the EPT or NPT entry would need to be made invalid, but flag that it's a legal way of invalid so that the hypervisor can then correct it basically under...
On an access to that page, you would need to special case
right
the situation and wait for the page to reappear.
Somewhere else.
Elsewhere, yeah.
And in fact, in a virtualized environment, do you even want the guest to have the NUMA page migration enabled? Because you have lots of guests, they might spend a lot of time migrating pages back and forth, basically overloading your system.
I think this should be a host administrator decision, right?
Yeah.
So it should not be a guest decision, it should be a host administrator decision, of course.
Yeah, I think the page migration, the mechanism, they did it in the Linux kernel, was using back then a multi-level strategy where they isolated pages as a first stage. And then they took these pages somewhat offline so that when they are accessed, the access is blocked, and the pages are then copied, and then there are made online on the new page range, on the new block of memory, and afterwards they are unisolated and the system is let loose on those pages again. So it was a multi-stage process, and I guess it would be like a very intensive task to do the things then.
I think we already have the framework. It's not supported officially, but Xen Paging is doing exactly that, right? So we just wouldn't need to put out the page contents to backing device, but to another position in RAM, and do exactly the Xen Paging stuff.
I would not have thought of doing it that way. I would rather have thought about doing it by marking a page temporarily as log dirty, just not globally as we do for migration, but just for a single page or a range of pages, and then deal with the rest without any paging involvement.
Yeah,
but
okay.
Whichever of the two approaches might be better is hard to tell without trying.
Thank you. Thank you.
Okay. Are there more questions? Yeah, if not, thank you very much for the suggestions. I think this was the last talk for the day.